Our next topic is the Smart App Platform, or the Smart on FHIR app platform for healthcare. And to give you a sense of the motivation here, it's useful to think from the perspective of a hospital or a health system that's trying to work with a number of different technologies day in and day out in the course of their environment. And we commissioned a report back in 2017 to look at some of the challenges here. So this is available at smarthealthit.org/apps report. And here was a quote from one of the participants who was a physician working with different technologies who said, "We had this wonderful population health tool, but we couldn't get our EHR system to interface with it. So we had to enter information by hand, and eventually we just had to give up because we couldn't physically keep up with that process." And that really captures the pain of working with health data systems that are not well integrated. And it sets the stage for understanding the importance of standards, not just for data, but for a whole collection of functionality that you need in order to integrate apps. So the core focus of the Smart Health IT project is really that collection of functionalities. So on the one hand, you've got a variety of healthcare apps over on the left of this slide, which might do specific jobs like managing diabetes medications or showing you whether a child is growing according to the expected curve. And on the other hand, you've got a number of different health data systems. So these could be electronic health record systems, but they could also be data warehouses or patient portals or other kinds of systems. And the goal is to make these apps as close as possible to plug and play so that any one of these apps can run inside of any one of these systems. And in the SMART project, we asked, what are the basic components that we need to make that work? So one of these is UX, or user experience integration. How do you physically embed the screen real estate of an app into the screen real estate of an EHR system that a clinician might be using throughout the course of their day? Another important area is authorization. So how do you give apps access to perform the functions that they need, to read the data they need to, for example, without giving them anything too broad? Another security aspect is single sign-on. So how do you make sure that users can authenticate to these apps, can be signed in to these apps without having to take any extra steps and without having to create new accounts for every app that they work with over the course of their day? And then, of course, clinical data. How do you give these apps access to a rich set of information about meds and problems and allergies and labs and all the other information that they might need in order to get their job done? And in SMART, the goal has been to take a standards-based approach and to use open standards anywhere that we can to get these jobs done. So for the authorization and single sign-on pieces, we use OAuth and OpenID Connect, which are web standards. And for the clinical data piece, we use, of course, FHIR. So what's the importance here? Why SMART? From a user perspective, the value proposition is really choice of applications. So you get your choice of a catalog or a store or a gallery full of different applications, and you can pick the ones that work best for you. And if a better growth chart tool comes around, you can switch away from the old one and swap in the new one and not have to start again by entering or connecting all your data. Your data live outside of the app. From a software developer's perspective, the important thing here is this really lowers the barrier to entry because you're building your app using open standards, supported by a big community. And once you build the app once, you can plug it into multiple different vendor systems and in different contexts as well. So you might run an app in the EHR real estate, but you might also embed it in a patient portal, and you don't have to rewrite the app in order to do that. And what this means is that you can make a new kind of investment. So for example, if you're building an app that's only ever going to be run inside of the cardiology department at your hospital, it doesn't make sense to invest that much engineering effort into really making it polished and capable. Just enough effort to make it work well inside of your organization, and then you stop. But if you can take that app and sell it or give it away to organizations around the world that have a similar mission to yours, well, then it really makes sense to put a little more investment in upfront and develop a level of fit and finish that's going to make it quite usable. And so in this sense, electronic health record systems become kind of a platform where the EHR is responsible for some of the core capabilities like managing databases of users and patients and permissions, managing workflow for core services like medication prescriptions, handling data persistence. So where do you store everything? How do you make sure that search works efficiently? Handling things like regulatory compliance, getting aligned with some of the certification requirements in the US. And then apps can plug in on top of that platform. And app developers don't have to worry about all those details. You don't need every app developer to solve the problem of data persistence over and over again. That becomes a platform feature. So I want to talk first about some of the authorization pieces. So when we embed an app into an EHR system, how do we launch that app in a way that gives it permission to the data that it needs to see? So in this diagram, there's an app represented by this box on the left and an EHR represented by the box on the right, and time is progressing from top to bottom. So this is what's called a sequence diagram. And what happens is we use a specification called OAuth. So the flow that you're seeing here, back and forth between the app and the EHR, is defined in the OAuth web standard. And in the Smart and FHIR spec, we lock down just enough details to make this work consistently in healthcare. So first, let's say an app wants to launch against an EHR, starting from the app itself. So this is what we call a standalone app launch. This is what happens when you run an app on your mobile phone and you want to connect that app to your health records. So for example, the Apple Health Records app connects using exactly this flow to production EHR systems today. So the user launches the app on their device, and they begin a connection process to the EHR, which sends them over to the EHR requesting specific kinds of data or specific scopes, which we'll talk about in a little bit. The EHR is responsible for signing the user in, making sure we know who's at the keyboard, and making sure that they want to approve or authorize access to this app. So the EHR will, after signing the user in, display an approval screen saying, it looks like you're trying to share your data with this medication app. Do you want to proceed? And if the user chooses to proceed, they get redirected back to the app, and the app gets some information that it can use to access clinical data. So it gets eventually an access token and a user identity token and some information about the context. So which patient record is open currently in the EHR, which patient record should it be working with? And now that it has all that information, it can begin to interact with the FHIR API in the EHR system. So it can issue a FHIR API request, like we talked about in the last module, to say, for example, I know I'm working with patient 123. I want to fetch all the demographics for that patient, or I want to look for all recent lab tests from that patient. And then the FHIR API responds with FHIR resources back to the app. So that's the basic OAuth flow for what we call a standalone app launch, beginning from a user running the app, maybe on their mobile phone or maybe on a desktop. There's one other important flow which builds on this, which we call the EHR app launch. This is particularly important for clinician-facing apps that need to run embedded inside of the screen real estate of the EHR. And you can see it looks a lot like the flow we looked at in the previous slide, with one initial step, which is instead of starting from the app, we start over here from the EHR. And maybe this workflow gets triggered when the user navigates to a particular screen or a particular tab in the EHR. So for example, if I navigate to a growth chart tab in the EHR, it might begin this interaction where it sends me then over to the app by opening an inline frame or an embedded window onto that app's URL. And then the OAuth flow proceeds just as it did in the standalone launch. At the end, the app gets an access token. It can use that to issue FHIR API requests and fetch FHIR resources back from the server. And this is an example of an app that then runs embedded in the screen real estate of the EHR. So that's why we call it an EHR app launch. Now, one of the important parts of that launch was the set of scopes, or the particular kinds of access that the app is requesting. In Smart, we try to follow the principle that an app should have access to all the data that it needs, but no data that it doesn't need. And so scopes help us lock down those details. It conveys a specific request about what information you're going to want for this particular app. And we designed a set of scopes that allow you to ask for specific information about specific patients. So let's look at an example. Let's say you're building an immunizations app that's going to be showing you a view about what immunizations you've had in the past and maybe making some recommendations about what you should get in the future. So in that case, that scope that the app needs might be something like immunization.read. So that's a scope specifically about the FHIR resource called immunization, and specifically asking for permission to read those records. Now there's also a prefix here, patient/. And what this means is it's a scope designed for an app that's working with one patient at a time. So an immunization records app might be one that's only showing you immunizations for the patient currently in context. So we'd ask for patient-level scopes. In a little bit, we might also talk about user-level scopes, which can be a bit broader. So other examples of scopes might be an app that is going to be showing you lab history. It might ask for a history of all observations within the patient access type, and might also need patient demographics to show you, for example, a person's age or gender or physical street address. So that app might ask for patient/patient.read and patient/observation.read. A more complex app that's bringing together data from across the patient record might try to read all data available about that patient. So that might ask for patient/star.read. Just to give you an example for writing as well as reading, an electronic prescribing app might ask for something like patient/medication order or medication request.write. And a population health app that's displaying data about more than one patient at a time might ask for user level scopes. So a clinician running a specific clinic might ask for user level scopes here to be able to look at data across all the patients in their clinic, all in one view. So those would be user/scopes. I also should mention that the scope system here is quite limited. It allows you to say some things like reading all observations, but that's still often broader than what you really want. So for something like a growth chart app, for example, if you ask to read all observations, well, it's better than asking to read the whole record, but it still includes all kinds of observations that you don't really need. Things like lab tests, maybe even sensitive lab tests, like an HIV value. Well, in FHIR, that's an observation. And so one of the limitations of the current smart scope language is that it doesn't allow you to go that fine-grained. It doesn't allow you to ask for heights and weights, but not observations. That's one example. Heights and weights, but not HIV status is an example of something that the current scope language doesn't allow. So I've also included a link to some design notes for ways that we're thinking about improving the scope system in SMART. This turns out to be a surprisingly deep challenge to do this in a thoughtful and extensible way that can be widely supported by real-world systems. And so what we have today in SMART is what I would describe as a kind of pragmatic approach to scopes. It's worth saying that one of the most important ways in which we've been able to push for adoption in the SMART specification has been by working with a number of communities, including the Argonaut project, which is a consortium of health record vendors, technology companies, and healthcare providers, where each year, since about 2015, the Argonaut project has been taking on a few use cases and building as a community implementation guides to tackle those use cases. And they range from things like basic data access with the SMART protocols, to scheduling, to better support for sharing clinical notes or managing subscriptions. Each year we pick off a set of projects, and the Argonaut project has been a really important way in the way that we've supported SMART. We started seeing adoption of the SMART Health IT specs as early as 2015. So there's a quote here from Ricky Bloomfield, who was then at Duke and now is at Apple working on the health record products. And Duke was an early adopter because they really believed in the value of these technologies, and they built their own support for SMART into their EHR at the time. But it was really only a few hospitals or health systems that could make that sort of investment early on to be able to run these SMART apps inside their system. Today, things have really changed. Today, support for the SMART on FHIR APIs comes built into a number of major production EHRs, so it's a much lower barrier to entry. One of the things that we do as a community is to publish a SMART app gallery to make it easy for developers to share the apps that they've built with the broader world and make it easier to learn about what apps are out there. Now, that SMART app gallery is free to use, both for app developers and for consumers who want to learn about those apps. And it's vendor neutral. So this shows apps that might run inside of any number of different EHR vendor systems, but we provide our own sample data and our own way to browse these apps and test out how they work. There's a set of screenshots here that show what the gallery looks like, and I do want to show a very quick demo to give you a sense of how this works in the real world. So a developer might list an app here, and maybe I'll scroll down and look at apps that are focused on medication management. So we've got a set of apps that deal with medications. And to show you an example of one that does translations on medication lists, I'm going to click the view button here for the Medication RS app. Every page in the gallery has a similar listing to this one, which includes a description of the app. It can include videos and screenshots, as well as information about current EHR support. So these are the EHRs that this medication app works in today: Cerner and Epic and Athena Health. And then information about the OS where it runs. Well, this is a web-based app, so it runs on any OS with web support. But my favorite feature of the Smart App Gallery is this button here called Try App, which allows app developers to point to a demo server that we host on the web and list an app and run the app against some sample data. Now, both the wonderful thing and the challenge of working with a live demo is that sometimes an app is up and running and other times it's not. So I won't be able to show you a live demo of this app right now, but I will show you a couple other demos over the course of this presentation. Thinking about other related activities in the smart health IT space, an important one has been the clinical decision support hooks, or CDS hooks framework. And the goal here has been sometimes just launching an app when a user clicks a button isn't enough. Maybe the user has hundreds of apps or even thousands of apps that they're able to run, but they don't know which apps are going to be important at any particular point in time. Some apps are only relevant under very narrow circumstances, and asking the user to keep all that in their head becomes unrealistic. So the CDS hooks specification provides a way to turn this model on its head and allow the EHR to send out event notifications to different CDS services in the context of the workflow. So maybe when I open a new patient chart or as I'm writing a medication prescription, I can get real-time advice from external services that suggests to me things like, oh, here's an app you might want to consider. So for example, maybe you're writing a prescription for a blood pressure medication, and an external service says, did you know that there's a couple of apps that you can use that will help you figure out the right dose of that particular blood pressure med? And that's what the CDS hook specification is designed to help with. There's also a set of specifications that we've helped develop on the Smart Health IT project to improve the use of FHIR for broader populations of data rather than just one patient at a time. And an important one here is the FHIR bulk data specification. And so this focuses on getting access to data across a whole population in kind of a batch format. So how do you do an export across the whole population and allow a client to then run analytics tools across that whole population all at once? And this has been a really powerful set of specifications that was published last year and is coming into broader adoption. The other thing that the Smart Health IT project supports is the development of open source tools for working with this Smart on FHIR API. And I'll show you an example of one, which is the Smart App Launcher. This tool lives at launch.smarthealthit.org. It's open source. You can run it locally if you want by checking out the repository on GitHub. But it basically provides an environment for testing apps against many different versions of the FHIR API. So you can choose between FHIR version 2, version 3, or version 4. And it simulates all the different launch types we talked about earlier. So the standalone launch, the EHR launch, and it allows a developer to pick out specific patients to try an app against, and then run an app against that patient. There's a number of configuration details here, and maybe the simplest thing to show you would be an example of what the standalone launch looks like. So I'm going to click through to this website here at glitch.me. Glitch is a website that lets developers post snippets of code, run them live on the web, and then also share them so that people can fork that code and make their own tweaks or changes. And you'll see that this example app sends me over to the Smart virtual sort of patient portal. This is a testing environment with synthetic patient data in it and some dummy accounts. So I don't need to know a password. This comes pre-filled. It says this login is for demo purposes only. But if I click the login button now, I will be given a permission screen that says the app is trying to access data about observations and patient demographics for the currently selected patient. And if I approve this access, I'll be sent back to the app, and it can call the FHIR API, retrieve some hemoglobin A1C values, and plot them here in the plot that you see on the screen, which is a temporal plot of previous lab results. So that's an example of what the Smart API looks like in action, going through the OAuth launch and then fetching data through the API. The code underlying this app is openly available at glitch.com here. And of course, these are all linked to from the slide deck. But I want to give you a quick sense that there's not a lot of code. This is the kind of thing that you can do with relatively minimal code. So there's two HTML files here involved in the code base. One is for the standalone launch. It basically just kicks off that launch by calling a function in our FHIR client library. So this uses an open source JavaScript FHIR client library that the Smart Health IT project publishes. And it asks for a particular set of scopes. These should be familiar from our review of scopes. It asks for observation.read, patient.read, and then one here called launch patient, which is to say, this is an app that's going to work on one patient at a time. So it's requesting that the EHR select a single patient record before the authorization process has completed. So this is what's needed to kick off the launch. And then once the launch completes, there's an index.html page, which is responsible for fetching the data and drawing a graph. And I won't go through all the details here, but I just want to show you, first of all, that it's about 75 lines of HTML and JavaScript, so not a lot of code to work with. And it, again, relies on our standard FHIR library. So it calls the OAuth2 ready function, which says, get an access token, make sure we've completed this OAuth process with the scopes that we wanted, and then call this first function here, call the getA1C data function. And this is responsible for doing the data queries. In this case, it's again using our standard library to issue a FHIR API call to fetch all observations with this particular LOINC code, which is a LOINC code for a hemoglobin A1C. And then it's going to do a plot. So for each observation it finds, it's going to go through the list of observations, pull out the effective date time. So this is what we'll use for the x-axis of our plot to know what time the observation was made. And then it will pull out the value quantity, which is to say, what was the value of the A1C level? How high was it? Once it fetches an array of those dates and values, then it calls an open source plotting library called Plotly to make a new plot of A1C values, passing in for the x-axis a list of dates, and for the y-axis a list of the numerical values. Passes in a set of axis labels and titles, and that's it. That's the whole app that's able to complete the OAuth process, fetch a list of data, and then plot them in this interactive hemoglobin A1C plot. Under the hood, that app is using the Smart App Launcher in order to connect to a Smart on FHIR service. So some of these libraries are built by the Smart Health IT project, others are built by different organizations in the community. But today, if you're getting started building a Smart on FHIR app for the web, or for iOS, or in Python, or in Java, or in .NET, or in Ruby, there are libraries out there that will help you get started. In some cases, it's full stack libraries like the JavaScript example that I showed a moment ago that covers everything from OAuth to the FHIR REST API. In other cases, there are just library support for communicating over the FHIR REST API, and you do the OAuth part yourself. But there's a number of libraries out there to help you. And if you're getting started, the strong recommendation is to check out docs.smarthealthit.org, which has a list of links to those libraries, as well as tutorials for working with these kinds of data. And the tutorials are a great place to get started. And as you're digging in then in particular languages of choice, we've linked to those language libraries as well. Part of what we've built in the Smart Health IT project also includes some richer open source sample apps that do things like calculating a cardiac risk score, drawing a growth chart, or showing historical blood pressure measurements normalized by a child's age and height and gender. Now, there are a number of public sandboxes that you can use to test out your apps. Some of these are from particular vendors. So from the Epic system, or from Cerner, or from Allscripts. Those are vendor-specific sandboxes where you can try out your code against that vendor's implementation of the API. I already showed you the Smart App Launcher, which comes with a sandbox of synthetic data records that you can use to try out your API. Graham Grieve, who's the principal architect of the FHIR specification, maintains a sandbox server from his Health Intersections site. And the HSPC, now called Logica system, also maintains a sandbox where developers can go and configure and test out their apps. My general recommendation here is to try to start with one of the open source public sandboxes like the Smart Sandbox, and then branch into some of the vendor sandboxes like Epic or Cerner, because it's important to understand where there can be small differences in API implementations across these different systems. If you build your app against just one server, you're going to find that there are aspects of how it works that aren't going to work with other servers. You can get to a point where your app is robust enough to work across these different servers. And so it's important to test with different servers so you can understand what those kinds of generalizations look like. What are some of the different conventions in the way that these different sandboxes or different real-world servers support these standardized APIs. So I mentioned the Smart Sandbox has some synthetic data. There's about 1,500 synthetically generated patients. There's also a smaller set of de-identified longitudinal medical records that reflect data that come from real-world health systems. I mentioned the docs.smarthealthit.org website, which has links to the sample data as well. So if what you want to do is download specific sets of sample data, we can point to the download site. It's a broken link, but that's something that we will correct in these slides. I mentioned the Smart Launcher, which is a configurable tool for trying out the various flavors of the Smart Launch. And one of the really powerful things that you can do here is if you're building a standalone launch or an EHR launch, you can test out your app using this tool directly. One of the tutorials that I want to give a shout out to is the one that's maintained by the team at Cerner. And there's a link here from the Cerner engineering blog that takes you start to finish through the process of building and configuring a smart app. One of the great things is you can test the app locally on your own computer, or you can test it on the web using glitch.com. And the tutorial will take you through that complete process. So that's where I wanted to wrap up today in terms of an overview of the Smart on FHIR app platform. We've talked about the Smart API and the OAuth process itself. We've talked about some of the related community efforts and given a quick tour of some of the tools involved in working with the Smart on FHIR API as well. Thanks so much for your attention.